Okay, so let's have a look at this problem here where we've got to evaluate this integral between 0 and 2 pi. So if you want to have a go at this by yourself, now's a good time to pause the video, otherwise I'll go through a solution. Okay, so this is something that it looks horrible, doesn't it? If we weren't looking at a definite integral, where you know the limits of integration, I'm not really sure if there's a nice way to solve it. So some of the first things we might look at would be maybe we can do some sort of substitution with u plus sine x, but then when you change variables, your du, you'll end up with something quite nasty in there, and I'm not aware of anything that would work with that sort of approach. But fortunately we're looking at something between 0 and 2 pi here, so we can try and use some properties of the fact that we're going between 0 and 2 pi, use the range of values to work out what the answer is going to be. So for me, when I see this, I'm seeing lots of signs in there, and it makes me start thinking about odd and even functions. And even though we're between 0 and 2 pi, perhaps if you have some sort of integral and we were to change up the limits of integration, if you had some sort of odd function, then you could show that its integral would be 0. So this would be, you'd say f is odd if f of x, or f of minus x, is equivalent to minus f of x. So this looks like, to me, maybe it could be some sort of odd function, but we've got a problem here that we're not actually going between, say, like minus 2 pi and 2 pi. We're going between 0 and 2 pi, so we've not quite got that sort of symmetry. And just to show what that would look like, if you like to think of your integrals in terms of positive and negative areas, perhaps you've got some sort of function like this. You've got your positive area here, your negative area here. These two cancel out, and that's why your integral between a and negative a will give you 0 for an odd function like this. Okay, so the first thing I'm going to do now is I'm going to do a substitution, so that instead of integrating between 0 and 2 pi, we're going to now integrate between minus pi and positive pi. And I'm just going to do a simple substitution here. U is equal to x minus pi. So then when x is 0, u is minus pi. When x is 2 pi, u is pi. And your dx and your du just stay the same. So let's see what this does to our integral. We're now integrating between pi and minus pi. Sine, so x is now u plus pi, plus sine of u plus pi once again, plus sine of u plus pi. Okay, so this has got a little bit more messy inside the integral here, but we can try and deal with this now. So I'm going to deal with this by, we can try and simplify a few things here, like for example sine of u plus pi. We know that sine of u plus pi, this is equivalent to minus sine of u. So we can actually get rid of the pi here, and we'll be able to do similar tricks with this pi and this pi, just to tidy up our integrand a little bit. Okay, so this is equal to minus sine of u. So let's rewrite our integral again. So now we're integrating again between minus pi and pi. We've got sine u plus pi plus sine u plus pi, but now minus sine u du, and then we'll get rid of this pi here. So you know that sine of u plus pi minus sine u, you can just replace this by, this is going to become minus sine of u minus sine of u. So it doesn't actually matter that there's this minus sine u inside this sign. We've just got some stuff plus pi. We've got rid of that pi, and now it's negative of that sign. Okay, so what does this give us next? It's starting to look a little bit neater. Sine of u plus pi minus sine of u minus sine of u du. And finally we'll get rid of this pi as well. So this tells us that our integral is going to be equal to sine, where this is now negative, because we're getting rid of this pi, and this turns this into a negative. So we'll now have negative sine u minus sine u minus sine of u du. So now what I want to do is, I want to show that all of this function, if I call this f of u, I want to show that f of u is odd. And what that means is f of minus u is always equal to minus f of u, or at least in our range between minus pi and pi. Okay, so how are we going to show that this function f of u is odd? All we need to do is we need to plug in, instead of u here, minus u, and hopefully we can show that this is equal to minus f of u. Okay, so f of minus u, this is equal to minus sine minus u minus sine minus u minus sine of minus u, and then our brackets there. And then hopefully we can try and tidy this up a bit, get it looking more like minus f of u by using properties of sine here. So you know, for example, sine minus u, this is the same as minus sine of u, because sine is actually an odd function. And we'll be able to use similar sort of tricks to get rid of some of our other negative signs in here as well. So what is f of minus u equal to then? If I leave most of this alone and just deal with the innermost sign, I get minus u, and then now this is going to be plus sine of u. So we've got a minus sine of minus u, which is equal to minus minus sine of u, so plus sine of u. So then let's do the same thing here. We've got a minus sign here, we've got a plus. So what we can do is we can say that minus sine minus u plus sine of u, this is equivalent to sine of u minus sine of u. And then we can replace this part. So that gives us now, leaving the outermost sign alone, so minus sine minus u, and now this is positive here, so we're plus sine of u minus sine of u. Okay, so just one more step then. I've got minus sine of minus u plus all of this. So what I'm going to do is I'm going to write this as, this is going to be positive sine of, so I make everything inside the function negative, so this becomes positive u, and then take away all of this stuff. Okay, so I've shown that f of minus u is equal to sine of u minus sine of u minus sine of u. And then if we look at what is f of u, well, f of u is just the negative of this, so this is indeed equal to negative f of u. So we wanted to show that f of minus u is equivalent to minus f of u. So we've done that now. And what does that mean for our integral? Well, the integral between minus pi and pi of f of u du, this is going to turn out to be 0, because we could split this up into the integral between minus pi and 0, f of u du, and then plus the integral between 0 and pi of f of u du. And then if I do a change of variables here. So instead of integrating between minus pi and 0, what if I just replace u by v equals minus u? Then what I'll get is I'll have an integral between 0 and pi of f of minus v dv plus just this same thing, integral of f of u du. But then we know that f of minus v, because we've shown that f is an odd function, this is equivalent to minus f of v. So this gives us minus the integral from 0 to pi f of v dv, and then plus the integral from 0 to pi of f of u du. And these two things are equal to each other, so they cancel. Therefore our integral is equal to 0. And this is okay because we're not doing kind of negative infinity plus infinity, because this is going to be a bounded function here, so we don't need to worry about any of that. So this is indeed going to be valid. So the integral is equal to 0.